everyone. Today I'm going to continue and talk to you about inhibitions. So they are actually, I'm going to make this look better. There are actually two kinds of inhibition that I'm going to refer. And the first one is a competitive inhibition, and the second one is a non-competitive inhibition. And the two characteristics we have previously talked about in previous videos are about the Vmax and the Km. And the Vmax in a competitive inhibition is actually unchanged, but the Km becomes bigger. So Km, as we talked about, we said it's the concentration of the substrate in order for us to reach the half of the maximal velocity value. But it actually is an indicator whether the substrate is connected to the enzyme in a very loose or tight manner. If we need less substrate, it means that Km is actually smaller. It means that the connection between the substrate and the enzyme is very, very harmonic and very tight. Okay, and if we need a lot of Km, it means that the connection between them is some say loose. Okay, so this is a very important thing for me to tell you. So if we talk about a competitive inhibition, it's look like this. Okay, so this you can don't look at that. So we can actually see that this is the inhibitor, and it actually looks very similar to the substrate. Okay, they are both in the active side of the enzyme, and like the name, a competitive inhibition, it means that they compete between each other. Who will go to the enzyme? Okay, it means that if I have a lot of substrate and a little competitive inhibitor, then it wouldn't matter. But if I have a lot of inhibition, it means that the enzyme couldn't reach the substrate, and the reaction will be actually not productive. Okay, so I said that the Km becomes bigger. It means that I actually, because of this inhibition, I need a very large concentration of substrate in order for the reaction to take place in the normal rate that I'm used to. So let's look at the graph of Line-Weaver-Burk, okay, about it. So this is the Line-Weaver-Burk about it. So the rule in those lines, because we talk about fractions, is that bigger things are smaller. It means that like fifth is smaller than quarter. Okay, so this is the competitive inhibition, and this is without the competitive inhibition. And we can see that the Vmax is actually the same like we said before, because this point, this point, the y-axis goes to the reaction axis is the Vmax. But the Km actually different. You see, it's smaller in the competitive inhibitor. It means that it actually is bigger. Okay, because bigger things are smaller, so the Km becomes bigger than without the N inhibition. So this is good. Now let's talk about a non-competitive inhibition. A non-competitive inhibition is a really, really different world. The Km is actually not changed, but the Vmax became smaller. So what is actually a non-competitive inhibitor? It doesn't connect to the you can see, it doesn't go to the active site of the enzyme. It actually goes to another site, to a regulation site in the enzyme. Okay, it goes to this regulation site, and even if the substrate is connected to the active site of the enzyme, the entire unit of the enzyme is not very active, because it makes a conformational change in the enzyme and really makes it not work. Okay, so that is why we have less enzyme. It means that it doesn't matter how much substrate we'll put. It's not a competition. Okay, the Vmax will be smaller because we have less enzyme in our system. But the Km will be unchanged. So how we see it in the graph, I'm going to show you. So this is the outer graph. So here we can see that it's the same principle that we that we mentioned before, that um, that if we talk about smaller is bigger actually. Okay, so the Km, which is this value, is the same. We said the Km is not changed, but the Vmax is actually what changes. Okay, we can see that without the inhibition, the Vmax is actually bigger because we have much enzyme, because we said smaller is bigger. So this is a small thing, means it's bigger. It's bigger, sorry. Now you can see everything. And with not competitive inhibition, it gets smaller because we had less enzyme in the system. Okay? So this is what I want to talk to you about enzymes. I hope you enjoyed the entire set of the videos. I'm pretty new in this, so please don't be harsh with me. I would like you to subscribe and write comments and everything. I have a very important thing to say, that I used with the pictures in the book Biochemistry, and this book is the 6th edition. It's by Berg Tomoziku. I'm sorry if I said it wrong, and Stir. And I hope you enjoy it. They have entire chapters about enzymes and inhibitions, and I hope you really enjoyed that. Have a very lovely week, and please write me comments or questions if you have. Goodbye.